What's going on, everybody? Welcome to the machine learning with Python. So in the last tutorial, we have learned about the linear regression. We have trained the model and predicted the Google stock market values 90% correct. In this tutorial, we'll mainly focus about classification. I will tell you about two types of classification techniques. But before that, what if you want to save the previous trained model? It is not always good practice to train every time. Instead, we save the trained model. So to save the model, we'll need Pickle. So let's quickly import it. So write import Pickle, and if you don't have Pickle, install it by writing pip install Pickle mix in. So you can see that requirement is already satisfied, means it is already installed in my system. Now simply we'll write a code here because we want to save the trained model. So write with open, and here we define our model name, so which is regression model dot pickle, and we want to write it, so write here wb and let's call it I. Okay, now simply dump our model into this variable. It will saved in our directory. So now to open it, write give any variable first. So write saved is equal to open, write a name which is regression m dot pickle, and we want to read it. So write here rp and say clf is equal to pickle dot load saved. Now let's run the code to see if we are actually getting output. So here we go, means we are saving the model and also reading that model. So to test whether it is saved in our directory or not, simply comment this part and let's run again. You can see here we have got accuracy, means it is saved. Also you can verify by checking your directory. So here you can observe regression m.pickle. Now let's talk about the classification. So if you recall, in linear regression, the main object was to find best fit line, means we wanted to predict the future values. While in classification, we want to divide our classes. If it is binary classification, we'll divide in two groups, and if it is multi-class, we'll divide based on number of class. So suppose we have data in 2D like this. So you can easily understand by visualizing the data that there are total two groups. But how will computer knows? So if we somehow manage to separate the data, we can teach the computer also. So this is the way. So this is the first cluster and this is the second cluster. But it is clustering. We'll come to that part also. But classification can be easier than this. So let's see how k nearest neighbor work. So here we have total three terms. First there is k, which is any constant value which we can define. Nearest neighbor means we'll find k number of nearest point from our point. So suppose our point is right here. So you can easily say that this point belongs to this group. And how you came up with this conclusion? Distance, right? So that's all we do in k nearest neighbor. We find distance between our point and k nearest point. So let's say k is 4. So first find 4 nearest point from this point, which is this, and I guess this. Now based on the majority, we'll decide the group for this point. So if we say this is group A and this is group B, then we can say that this point belongs to group A. Now what if our point is right here? In 4 nearest point, 2 point belongs to this group, B group, and 2 point belongs to A group. Means there are 50-50% chance. So that's why we always prefer the odd value of K. Hence, this issue can be eliminated. Now, for 5 nearest neighbor, if 3 nearest points are present in A and 2 points are in B, then we'll say that point belongs to A group. But accuracy will be 3 by 5. Means 60%. So basically, more the point nearer to group, more its accuracy. So that's all for K nearest neighbor. In the next class, we'll pre-process the classification data and we'll try to implement K nearest neighbor using scikit-learn. Thank you.